Hello guys, it's the Caribbean Bookworm, and today I'll be giving you 5 tips on improving your mathematics regarding whether or not you're a high school or college student. So I know it's a different type of video, it's not a booktube video, but still, since my intro features not just book lover but science and logic, I thought why not actually explore that science and logic parts. It is a part of my intro. So we have a different setting. This is my actual bookshelf, by the way, guys. The one that you see in the previous video are not mine. They're my brother's bookshelf. I just like to film there because it's the most quiet place of the house. But still, this is my actual bookshelf, and yeah, why not? Let's go. So this video was made with a particular book in mind, and that is A Mind for Numbers by Barbara Oakley. A great book about tips regarding getting better in mathematics and the sciences, especially for like high school students. Essentially, I haven't read this book, but I saw some of the tips given in the book, and they're very amazing and very accurate regarding what it's like studying these things in high school, like when you have, like, say, AP Physics or AP Chemistry or AP Math. So I thought, why not make this video for those of you struggling with especially mathematics. Tip number 1 is to try your best not to memorize things. I know a lot of people have the tendency to memorize equations and memorize concepts, but on the long run, what tends to happen is that people memorize things, and they memorize things really well, but during exam, it happens that you just black out. You forget everything that was mentioned because you see this one simple problem which you can probably solve, but just because you remember the concepts and equation, you're having too much of a hard time remembering those than to actually think critically. So that becomes like a barrier instead of a helping ground for you. So memorizing things, it's good for certain subjects, but that subject would not be mathematics. Sure, you have to memorize some things, but they have to be like stepping grounds of which you build on, since mathematics is more of a conceptual subject. It's more about understanding the fundamentals, the basics, than just memorizing all these different facts. Tip number 2, if you're stuck at something, then do feel free to ask either your teacher or someone who understands the material. This could be a classmate or someone else from school. But if you go and ask especially like fellow students and classmates, then first you'll build a much better relationship with them, even if you didn't know them really well. And second, a lot of times studying in a group is what helps you persist with the subject, with the sciences and mathematics. I hear a lot of times in videos from people which study these things at a university level, how they say that if it weren't for their study group, and by the way, it doesn't have to be a big study group because that's also kind of dangerous, but if it weren't for their study group, then they wouldn't have been able to gone through their degree with such ease or with such manageability, I don't know if that's a word, and ask people with greater insight in general if you're stuck, because this will help you immensely when you're stuck at something, and they might be able to even show you what you did wrong at a certain problem. Tip number 3 is to try to make connections when learning certain new concepts. So when you're learning something new, like say exponential growth, see how this relates to something you've already learned, and see how this relates to something that seems quite the opposite. I know a lot of people know this, but some people actually really don't know this, but the logarithmic function and exponential function are just basically inverses of each other, so they're the exact opposite of each other. Or in the way that division is the opposite to multiplication. So these are inverses of each other, and such concepts, such connections are what gives you a deeper insight into mathematics. Making connections is not a guarantee like point to getting straight A's, but it is a good point to give you a deeper insight, which is what matters on the long run. Tip number 4 is the super important one, and it is the most obvious one, but also the hardest one, and that is to simply just practice. In mathematics, this is not geography, this is not history, this is not something yet that you can like binge study at night before the exam and think that you're going to get like a B or something. I'm trying not to offend anyone. I hope I don't offend anyone. But with mathematics, you do have to work through different problems in order to gain a solid grasp of a concept or an idea, because essentially you're going to get that exact same idea but just placed in a certain context, which if you didn't like prepare beforehand for it, you'll get super confused and you'll think that you don't understand anything of the certain problem, and you leave it open and you lose points and you gain a bad grade. So making a lot of problems will prevent this as much as possible. And keep in mind here, you don't have to just make problems from your textbook, but look for problems online. Like use things like, I heard a lot of people using brilliant.org, or use Khan Academy, or use other things to find problems online, and ask your teacher for more problems if you want to practice even more, because he or she will essentially give you like an old exam of which they themselves made. And this is super important because those old exams are as particularly what you'll be getting most of the times. You'll be getting the same type of problems asked, but with different stories or in different contexts. But essentially, it's usually the same type of question. So making especially these old exams of which your teacher gives you, if you go and ask them, you'll be better prepared for the exam. Tip number 5 is a mistake that a lot of students make, and that is to try your best to avoid the solution sheet. A lot of people go for the solution sheet as soon as they hit a wall. As soon as they've worked on this problem, they've worked on it, and realize that they're not coming anywhere, they decide to, oh, I'm just gonna look the answer. What happens next is, oh, I understand it now. I see how they got there. But in reality, you didn't see how they got there. Otherwise, you would have made it, or you would have corrected your mistake, or you would have said, oh, I have an idea where I've gone wrong. But you didn't do any of those things, so essentially, you didn't really understand it. This is a sort of confirmation bias of which every student, including myself, sometimes fall for. You look up an example or you look up the solution sheet and you think, oh, I know where I've gone wrong, and usually the exam proves you wrong. So in order to not let the exam prove you wrong, you need to essentially, when you're stuck at a problem, just keep thinking and start, what are the steps that you need to take in order to solve this, like this, that, and see if you've gone wrong in one place in that list. And if you don't see it, go ask your fellow student or your teacher. Essentially, try to understand where you've gone wrong before looking up the solution sheet. I can't stress how many people make this mistake, and essentially they end up not understanding anything, and when they go and make the test, they make it bad, they get a bad grade, and then get frustrated. So try your best to avoid the solution sheet unless you actually understand what went wrong and you're just willing to look up the solution and see if you're right about that idea. Now, before we finish this, I know you've enjoyed our lovely math talk, but before we finish this, I have one last bonus tip. So for those of you who wish to pursue the sciences, the STEM field, basically, a tip that I have in mind is to start working on proof-based mathematics. Like, try to start looking more and more into proofs rather than just plugging in numbers and manipulating equations, what high school math and even AP math basically is. So you have to start thinking a bit more deeply and more abstractly, because the concept is just going to get more and more abstract. So in order to prepare you for this, I only found 2 really good book recommendations, one of which I already have but haven't finished because it's really thick, and the other of which I don't have but I've seen great reviews on it regarding the topic of proof-based math. And the second one is a book called How to Prove It by Daniele Vellum. I heard great things about this book, and this book is essentially a book on the 4 basic methods of proving things in mathematics. So it isn't a book filled with just equations and proofs. It essentially goes through these equations and theorems with you, and it also has practice problems, so you'll be able to work with this concept and gain a solid foundation regarding proofs. The other book is a book of which I have, but I haven't read through completely because, again, it's very big. It is the book called Basic Mathematics by Sergi Lang. The book is basically, the book is about what the title suggests, basic mathematics, as in high school mathematics and AP mathematics, the math you need if you decide to pursue the sciences and maths further. So the book has all the things you're already familiar with: linear equations, quadratic equations, matrices, vectors and such. But essentially it works through the proofs to getting to these places. So indirectly the author prepares you for that proof-based mathematics, and that is what I found really amazing about this book. Unfortunately, it is not a book that is talked about a lot online, but I like it as a textbook. It's a very, very well written textbook in my opinion, or for what I've read so far. So How to Prove It by Daniele Vellum and Basic Mathematics by Sergi Lang. I really recommend those two books to those of you who are interested in pursuing these fields at a higher degree. So that's it for my video. I hope you enjoyed the video, and I'm sorry that it's not about the typical bookish things from the booktube community, but if you are someone from the booktube community and you've watched it so far, then a million times of love and warmth to you, my friend, because it's very, very hard, I imagine, for someone from just the booktube community to just watch through a video about studying and maths, because it's not essentially our field of interest. But anyways, I hope this video essentially is helpful to some of you guys, since that is the goal. And if you enjoyed this video and if you want to see more of this type of video or more book videos, then please leave a subscribe for me. Like, that would help a lot. I try to make as much of these videos as I can, and I have a grueling school routine, so making time to make these and especially edit and upload them is very, very challenging, but I try my best because I love doing this. And if you guys were to subscribe, it would really help a lot. So I hope you guys enjoyed the Halloween season, and see you guys very soon with another book review. Bye.